Hello, everyone. Good morning.
Good morning.
Dear, dear authors and invited guests, welcome to the technical session 4A. Myself, Aarti Mohan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Congress on Information and Communication Technology ICICT 2025, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, and the virtual event is being held through Zoom from 19 to 21st February 2025. I hope you all would be enjoying this knowledgeable session throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answer session round. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any sort of queries or any update, you can write it to me in the chat box. Just before we get started with the session, I would like to introduce you all to the chair for this session. We have Dr. Prin Sukriket. He is presently working as a professor at Finn School of Business and Tourism, Bangkok, Thailand, with a doctorate in business and specialization in blockchain, IoT, and AI. He has more than 20 years of combined executive and academic experience. His expertise lies in cultivating strategic partnerships, driving educational excellence, and steering technological innovation. We have Dr. Preeti Parvekar. She is a professor in the Department of Computer Science Engineering at GITAM University, Hyderabad, India. She has been an academician from the last 23 plus years. She is a member of IEEE, ACM, and CSI. Her research interest includes Internet of Things, cloud computing, machine learning, wireless sensor networks, software engineering, information retrieval systems, social media, data mining. It's a pleasure to welcome you, ma'am, on board.
Hey, thank you, Aarti.
Now, I would like to start with the presentations with the paper. I would request Byron to start present the paper on the paper title Classification Algorithm to Predict the Risk of Fetal Death in Ecuador. Could you please start with your presentation?
Yes, please give me permission to present my screen. Thanks.
Yeah.
Can you confirm if you can see the presentation, please?
Yes, the presentation is visible. You may please start.
Thank you. Greetings to everyone. My name is Byron Albuja, and I will present to you the results of the study entitled Classification Algorithms to Predict the Risk of Fetal Death in Ecuador. The complete list of the authors is presented at the bottom of the slide. First, a brief introduction to the topic. The term fetal death refers to the spontaneous intrauterine death of a fetus at any time during pregnancy. According to UNICEF, around the world, a fetal death occurs every 16 seconds. That's about 2 million deaths every year, and many of these could be avoided with adequate controls throughout the gestation period and with good medical care during childbirth. Among the factors that contribute to an increase in fetal deaths are socioeconomic level of the mother, geographical area of residence, health condition of the mother, quality of prenatal care, and whether health centers meet the requirements for basic operating standards and the necessary number of competent professionals. This shows that the risk of fetal death may significantly vary inside a country, as it is highly dependent on socioeconomic and geographical data. Some similar studies have been carried out around South America to try to predict the risk of a fetal death in pregnant mothers. For example, we have this study from the PhD Gamara Arturo, who used around 4,000 records of fetal deaths with information of the mother's health in the country of Peru. He trained decision tree, Bayes networks, and neural networks to predict the risk of fetal death. On his work, he concluded that decision tree showed the better results or performance for the prediction of the risk of a fetal death. The study, carried out by the Sabat et al., performed a statistical analysis with who that used over 4 years of fatal deaths data from Brazil, which includes socioeconomic data from the mothers and information of the mother's health. It concluded that the increase in the rate of fetal death in pregnant women within the range of 25 to 44 years was associated with increase in gestational risk with age, while the increase in the range of 10 to 14 years is associated with the decrease in the quality of public health policies. Finally, the analysis performed by Michelle Cruz carried out a binary logistic regression model with socioeconomic data from the mothers and information of the mother's health. It used 9 years of data from the country of Ecuador. As relevant conclusions, male fetuses are more likely to die. The fetal mortality rate increases in mothers who had less than 4 controls during their pregnancy. There is a lower death rate in mothers of higher education level, and the probability that a woman of indigenous ethnic origin will have a fetal death is 8 times higher compared to Afro-descendant, Montubio, and white women. This figure shows the number of fetal death cases in Ecuador from 1990 to 2022. The country has an average of 5.9 fetal deaths per every 1,000 successful births, which is high compared with the 2.9 ratio in developed countries. It stands out that during the last 30 years, the number of fetal deaths have never gone below 250,000 cases in the country. For this study, publicly available data of fetal deaths and live births in Ecuador from 2000 to 2021 was obtained from the National Institute of Statistics and Census of Ecuador, also abbreviated as INE. The total available records on each category are shown on the table. It stands out that the fetal death category has a lower number of samples than the live birth category. Indeed, it only represents 0.6% of the total records. Due to the extreme class imbalance, oversampling and undersampling methods were used when training the classification algorithms in this study. The main objective of this study was to train classification algorithms to predict or identify the risk of fetal death in pregnant mothers. The algorithms use data based on their socioeconomic and demographic data. A total of 6 classification algorithms were trained, which include decision tree, random forest, neural networks, Bayesian classifiers, k-nearest neighbors, and naive Bayes Bernoulli. The classification algorithms were carried out in Python as a programming language, and during the algorithm's training, the tuning parameters were varied using an heuristic methodology. A total of 18 different categories of information was collected for every case of live birth and fetal death to train the algorithms. In this slide, you can see the detailed categories. The first categories include personal information of the pregnant mother, as well as information about the actual and previous pregnancies. You can see that we took into consideration many personal data about the mother, like the week of gestation, sex of the fetus, the state of the pregnancy, more personal data like mother's age, the number of living children, and everything you can see on the slide. It has to stand out that a very important data was the attendance at prenatal checkups. As it was mentioned earlier, this is highly associated with the risk of fetal death. On this next slide, we can see the socioeconomic information about the mother that was used for the training these algorithms. The socioeconomic information, as mentioned earlier, is highly correlated with the mother's education level and with the place of residence. So we took also another type of information into consideration, for example, the mother's ethnicity, the mother's educational level, the province of residence as mentioned above. The socioeconomic data is also important in the objective of predicting the higher risk of a fetal death in a pregnant mother. Regarding the results of the study, the following table summarizes the percentage of correct classification for fetal death categories for each type of algorithm. From the results obtained, these observations stand out. A single decision tree showed a higher performance in comparison with a random forest algorithm. The difference can be seen on the table. Using the undersampling and oversampling techniques, the decision tree always shows a better performance. Also, the performance of algorithms trained with undersampling methodology is higher compared to those trained with oversampling. In all the training cases, the neural network had the highest performance of all the algorithms. The neural network algorithm trained with the undersampling method was chosen as the best of all the alternatives. The algorithm with the best performance was selected by its ability to classify the fetal death category with the lowest percentage of error. As the category of fetal death occurs very rarely, the challenge for the algorithms was to identify it with the lowest possible error rate. The table below shows the confusion matrix for the neural network algorithm final test. The neural network training with undersampling classified incorrectly only 4 of the cases used for testing their results. So it stood out as the best performance algorithm from all the 6 different algorithms trained.
Dear presenter, could you please conclude your research?
Of course. In this slide we can see which of the categories or data used for training the algorithms had the highest impact on the decision made by the algorithms. So we see that, for example, the weight of gestation and the number of actual children of the mother, as long as the mother age, were between the variables that the algorithms use the most to classify correctly any record. As conclusions, the results of the study lead to the following conclusion. First, the performance in classifying fetal death records was better in algorithms trained with the undersampling methodology. From all the training algorithms with undersampling methodology, the neural network had the best performance. The superiority of the neural network in the classification task is attributed to the fact that this algorithm is not based on learning classification rules. Instead, it assigns different weights to each input data to calculate a percentage of security in the register classification. In this way, it can prioritize information that facilitates classification and penalize or consider to a lesser extent those that are not very useful. It is important to emphasize that the results obtained with these algorithms are not intended to replace the diagnosis of a professional, as the results are not based on any clinical data. The algorithms are just a tool to help the professionals to identify a possible higher risk of fetal death based on socioeconomic and demographic data of the pregnant. Thanks to everyone for your attention.
Hello, Byron. Can you hear me?
Yes, I can hear you.
Yeah, it's a good research work. I have just one question. Is during your research, have you observed anything? What was the fetal death was common in some particular age group or any other observations?
It stood out that there was a really mixed results, but the variables that help the algorithms to
Hmm.
try to identify the fetal death case were many of them. The most important variables, as mentioned before, we have the gestational week, the
Mhm.
number of children that the actual mother has, also the number of children that have died in similar circumstances or fetal deaths that occurred before for the mother, and also the mother's age were between the variables that had the most the neural network to decide if it was a possible fetal death case. But we couldn't see any relationship in specific age groups or specific geographical areas. The results were varying a lot in that case.
All right, okay. The data set, was it ultrasound images?
No, it was socioeconomic and demographical data. So we used the 18 socioeconomic data and personal data mentioned before that are presented right now at the slides.
All right, thank you, and all the best for your research.
Thanks.
Thank you. Thank you so much for your presentation. Moving on to our next presentation. We have uh, the paper Creating an Academic Performance Management Model for Higher Education. Dear presenter, could you please start with your presentation?
Yeah, yeah. Good afternoon, all. I hope my screen is visible.
Yes, Jaya.
Yes, ma'am, it's visible.
Okay. Yeah, so the paper ID is 24, Creating an Academic Performance Management Model for Higher Education is the title of the paper. The paper is written by Dr. Jaya Chitranji, Dr. Rajiv Divekar, and Reena Lenka. So, actually, this paper is about the performance of students in an institute of higher education. So, student development and growth is the result of the academic performance of students. Academic performance of students depends on the academic rigor that is there in the academic program, the processes that are there, and the vision of the institution. Student performance management should focus on the holistic development of students. Otherwise, it will have only a partial view of the performance of students. Institutions of higher education should manage performance of students based on performance metrics. They should measure individual and group achievements of students and then accordingly should give them some scores for their performance. These systems acknowledge diverse learning styles that are used by as per the needs of the students. So the focus of this paper is on student performance management. It inculcates a culture of professionalism and commitment to the organizational excellence. Because if the focus is on the performance of students in an institution of higher education and students and there is a system through which the performance of the students is monitored, then the institute will benefit because the institute will be coming out with students who are better equipped for meeting future challenges, who are performing and whose skills and learning can be monitored, and the institution can work on increasing the performance of the students. So the changing vistas in performance management bring in the global context in terms of student performance management and thus introduce internationalization as a key component. This is extremely important. So this slide is about the literature review. The pursuit of student performance management entails developing a model based on student learning. So in Ghosh and Das in 2014, they tried developing this model and they highlighted the importance of continuous and interactive performance management, which means performance should be managed on a continuous basis. It's not that performance should be managed at the end of the term or at the end of the year. It should be continuously managed and it should be interactive, which means that there should be an interaction that is taking place between the people who are measuring the performance and the students whose performance is being measured. Cousins in 2014 suggested combining performance drivers to the performance measurement system, thus proposing a dynamic system of performance management. The key drivers of the performance of a student should be taken out and the monitoring of their performance should be done vis-a-vis those performance drivers only. Slabert et al., Slabert and Parsons in 2001 emphasized, so it is way back, they emphasized that a thorough and rational performance management system for higher education would be built around workload determination and performance quality indicators. So we talk of all of these concepts with respect to employees, but then the researchers have put this on record that for students also we should measure the workload, which means the amount of work that the students are doing, and we should identify the performance indicators, and then only we should measure their performance. Koi et al. In 2023 suggested a customized performance management model for curriculum performance evaluation. So they actually noted that as per the academic program and as per the courses that the students are doing, performance management parameters should be decided and the performance should be measured accordingly. Cristano et al. Employed the analytical hierarchy process in conjunction with the academic scorecard technique. So academic scorecard technique is when you are giving scores for certain parameters that have been taken out from the academic journey of a student, and an analytical hierarchy process actually suggests what should come first, like what should, like maybe coaching should come first and it should be followed by maybe some amount of mentoring, and if there are some problems then maybe counseling is also needed. So there has to be a hierarchy of the process that is employed. Besides, others actually have also found out, they have also emphasized on the relevance of having a performance management system which is actually going by certain parameters of performance and which is using the scorecard approach also. So we have listed certain some literature, some citations here, like 2022, Alvarathan et al., Neurai et al. In 2025, and Jones and Bunce in 2019. So everybody is actually talking of the time and effort that is required, a cognitive strategy that is needed on, and certain parameters that have to be there. Student consumer orientation has to be there, which means a student centric system should be there, grade goals should be there, academic performance should be measured. And even in Rodriguez et al. In 2022, in 2020, they also found that a positive relationship between socio-economic status and academic performance in higher education. They also found that prior academic performance and university experience and working status as more strongly associated with academic performance in comparison of socio-economic status. So all if we if we analyze the literature that is available, the notion that comes to our mind is that we should be quite professional about measuring performance of students and managing performance of students. So and those indicators should be, those parameters of academic performance should be laid out after focusing on the academic expectations from students, and then we should come up with a system. So based on this literature review, and a gap was identified with respect to the existence of a performance management model for students in higher education that focuses on the parameters. Hence, the paper focuses on developing a model for performance management of students in higher education. And this model is suggested in this paper, and this model has 9 steps of performance management for students in higher education. This model is based on the assumption that students at the higher education level have reached that level of maturity where they can work and improve their performance by putting efforts themselves consciously. So there is a lot of emphasis on the student maturity also, while when if we are using this model, because if children are younger, then the onus of their performance of the development of students actually lies on their parents and on their teachers. But here the onus of the development and the onus of the performance of students in higher education lies on the students themselves. So we tried developing this model of performance management for students in higher education based on a thorough review of existing literature. So the present model is designed to increase the performance of students in higher education through the following steps: goal setting, coaching and guiding, performance measurement 1, mentoring, counseling, performance measurement 2, performance aggregate for all the goals that were planned in the beginning, reward or advisory, whatever is issued, and then new goals or revising and recalibrating goals for the next cycle, for the next performance cycle of students. So here you can have a look at the model that was developed, and actually there was a system that was developed, and these were the steps of that system. So first of all, we will start from goal setting. So where the goals for the students are actually set. So we are only talking of the higher education sector, where the goals for the students are set, keeping in mind the performance expectations. So this is the first step. Second, coaching and guiding. So coaching is when the sessions are happening and the classes are held and the students are actually coached to prepare for certain things. These certain things can be some subjects. These certain things can be some co-curricular activities and their performance with respect to those co-curricular activities. And these certain things can also be some extracurricular activities also, which are important for students. So if we talk of the curricular activities, these will include the subjects that are being taught. If we include the co-curricular activities, these will be maybe some internships, some case studies, or some life projects maybe that the students are working on, and extracurricular activities will be certain maybe case competitions or certain B school competitions or certain where the students are participating. Besides, along with coaching, guiding will also be happening, should also happen simultaneously, which means the student should be guided in which direction should they proceed and what should they do. So then comes the performance measurement. Once they have performed, then performance measurement should be done. And this performance measurement will happen with respect to the parameters that were set. And then some mentoring should happen. Mentoring is where there is a mentor and there are mentees, and or these students are there, and then when we talk of mentoring, we are actually talking of a long-term relationship where the mentor is actually working with the mentees and guiding them how can they use their potential. Then counseling is the next step, fifth step. In case there is some problem and the students are, even after mentoring, the students are not able to focus on their performance parameters, and they are not able to improve their performance or work on certain things, that and in case then some counseling is also required, where the person has to be trained into it. So a counselor is also needed who will see if the student is not able to perform, or if he is able to perform but not able to reach a certain level. Then performance measurement is the sixth step. So this is the performance measurement which is conducted again, because again the student has performed, again his performance is measured. Then performance aggregate for the, so this till step 6 the process can be repeated as many times as possible, then or as many times as required. And then performance aggregate for the goals, which means you will combine the performance of the students with respect to all the goals that you had set. So they can be co-curricular, they can be curricular, they can be extracurricular activities, but you will combine the scores of all and you will have one score. Based on this, some rewards or punishments will be given. Rewards can be any reward, any a certificate or some scholarship or something, or and a new goal can be decided for the students for the next cycle of performance. Or otherwise, if the students' performance is not up to the mark, then an advisory can be issued, and then based on it, the goals can be changed. Either you can lower the goals or you can increase the difficulty level of the goals. One thing that is important is that continuous feedback has to flow throughout this process. So continuous feedback, a two-way feedback, which means that a feedback system is also running parallelly along with this system.
Dear presenter, could you please conclude your research?
Yeah. So in order to improve a student, so this is the gist of this study. In order to improve a student performance in higher education, a 9-step performance management model was proposed in this study. These actions include creating goals. This was a step 1, creating goals where a student should have objectives for a single term, because in the second term the goal can be revised. Then performance measurement, which is used to evaluate performance in relation to the goal sets. Third one is coaching and guiding, which is used to help students reach the goal sets. Fourth is mentoring, which is used to assist students in discovering their strengths, potential, chances for future work, and opportunities for improving performance in relation to the goals that were set. Counseling is the fifth step, which should be provided to students in order to assist them pinpoint areas in which they are still falling short of expectations, or in which their potential is not being utilized properly. Performance measurement is the sixth step, which should be conducted in order to evaluate performance again. And this can be repeated again and again, this step of performance measurement. Then performance aggregate for the goals that need to be evaluated in relation to a particular objective, and for all goals put together after that. So there is one score that the student is getting. Based on that, certain awards are given and certain recommendations are given, which ought to be determined by the whole of the performance, which means a combined score for the performance. New goals or revising the or calibrating the goals happens next, where new goals may be set or existing ones may be revised or recalibrated for the upcoming term based on the reward or advice uh, for the total performance. It is vitally important to provide continuous feedback to higher education students uh, during the performance management cycle, since it gives them a clear path for performance improvement. So that's all from me. And the model will help to streamline the process of performance management for students in higher education. The model will also ensure involvement of teaching and non-teaching staff in performance management of students. And the model will also enhance the overall performance of the institute.
All right, Jaya. I have some couple of questions for you.
Yeah.
Yeah, this you have done for the higher education, as I understand.
Yeah.
Okay, so have you implemented it, or is as of now, what is your progress to this study?
Yeah, actually, this is a patent that, and this is a patent that we published this work as a patent, and this is one part of that patent.
All right. So in this, have you implemented the study, the model which you have proposed? Did you implement it?
Yeah, the implementation is still going on at at the institute level.
All right. So partial implementation has been done so far?
Yeah, we are working on this model. Like we have got a patent for this for the work, and now we have this system in place, and we are working on this model so that those trials and etc. those are happening.
So this is like if you're doing this, somewhere you have mentioned during your presentation that it
Yeah,
depends on the understanding of a student and their maturity level. So
yeah.
this higher studies education, what you are doing the study, is it for which age group or is it belongs to a specific graduation?
Actually, this study belongs to a specific graduation to management students.
Okay, so it's for
Yeah,
MBA, I guess.
yeah. This is for MBA
MBA
students.
and MBA students, as I
Yeah,
understand.
only MBA students. I actually forgot to mention that, but it is
Okay.
meant for them only.
Yeah,
And
so you can mention that one thing.
yeah, it should have
And
been.
second thing is like when you go for mentee and mentorship, there will be lots of other parameters to affect. So it's a small suggestion to you, like when you are implementing the complete model for the higher education, please test the model, whether it is really helpful for the students. You can have some testing methodology which can you
Okay.
can take the feedback from the students if they would like to add something to the model, and if not, then how does really this is helping, so that would be one more additional dimension to
Yeah.
your studies.
Okay, but the trial work is actually going on, and we have collected feedback also from students, and we have developed this model further also. So
Nice. And after
actually,
the complete implementation also you can test it.
yeah, the suggestion is well taken.
All right, good luck, Jay.
Thank you so much.
Thank you, ma'am. Thank you for your presentation. Thank you, ma'am, for your feedback. Moving on to our next presentation, we have the paper title Deploying Large AI Models on Microelectronics with RISC Framework, Federated Learning for Energy Monitoring and Robotics. Dear presenter, could you please start with your presentation?
Yes, just let me share and see. Okay. Okay, I think now. Let me know if you can see my presentation.
Yes, it's visible. You may please
Okay.
start.
Okay, thank you. So, good morning, everyone. I'm Iraklis Varlamis, and I'm going to present you a work that we have done in the university with my colleagues, Christos Kronis and George Dimitrakopoulos, and also from two collaborating professors from the National Technical University of Athens, Konstantinos Tepes, and Faisal Ben Sali from Qatar University in Qatar. We are coming from Harakopio University of Athens, which is another university in the capital of Greece, in Athens. So the work that I'm going to present today has to do with a proposition on how to deploy large machine learning and AI models on edge devices. So we propose an architecture and we demonstrate how this has been done in two different scenarios. So starting with the motivation of our work, we see that there is an expansion, a very high rise on the use of Internet of Things devices, which increases yearly at a very high rate. We also see that more and more sectors, daily sectors such as smart cities, healthcare, manufacturing, are adopting AI solutions and use AI models in order to provide solutions to the end users. However, these solutions and these models are usually huge, and they have several requirements that have to be supported by the available hardware. This rise of AI and this expansion of IoT devices is giving, let's say, a very quick shift to this solution from a centralized cloud-based, let's say, solutions to solutions that run on the edge, and we call them edge AI. In order to address the issues that we have when deploying our solutions on the edge, we have to understand what are the main constraints that we have on the edge. And first of all, we have resource constraints. We have devices like Raspberry Pi or Jetson Nano that have limited computational power, limited memory, and usually they do not have infinite, let's say, energy, infinite power to run all these heavy applications. So it makes very challenging to deploy large and complex AI models to these devices. The other constraint that we have is that in several applications, we require real-time response from these models, especially in time-sensitive applications, such as applications in smart buildings or when we're trying to do autonomous robotics in different setups, in different spaces. So there is no, let's say, there's no option for sending information to the cloud and waiting for the response from the cloud. So we have to respond in real time, running everything on the edge. In this work, we have worked and we demonstrate our results on two different scenarios. The first one is energy consumption monitoring. There we have a set of sensors that gather data, and we use LSTM models for predicting future consumption in order to generate recommendations to the end users to switch off some devices that will consume a lot of energy in order to reduce, let's say, their energy footprint. And in the second scenario, we have focused on multi-robot and multi-human collaboration, mainly for the path planning, let's say, of robots within an area. And also we use computer vision models such as convolutional neural networks or YOLO architectures in order to detect obstacles in real time and try to avoid them. So we focus on models that mostly perform computer vision tasks. For setting up our architecture, we choose different solutions. One solution is federated learning. This is an ideal solution for edge AI for various reasons. First of all, because federated learning, in essence, splits the models into different nodes, into different devices, allows the models to run on the different devices, and instead of sharing the data with the cloud engine, they simply share the local trained models with the cloud and aggregate the trained models on the cloud and update this aggregated information back to the edge node. So it allows to train the model in a distributed manner. And this offers data privacy, of course, because we do not share the data that is collected locally with the cloud. So for example, in a smart home monitoring, for example, application as we have, we don't require the houses to share their consumption data with a cloud provider, and they can train and use their local predictive models locally in a local manner. And then we have reduced communication overhead because we avoid sending all this data back and forth. Finally, we are able to address overfitting and catastrophic forgetting, which are two major problems that happen when we train a system and when we train a model continuously over time with new tasks, with new events, with new situations. And locally, usually long-term, these models tend to forget what they have previously learned. With federated learning, it's not possible because we share knowledge from different models. We aggregate this knowledge and we update our models in this way, capturing all the possible situations that may happen in a distributed manner. And then we have two other solutions at hand, which is model compression and model partitioning. These are two techniques that can help the machine learning models or the AI models that are huge to become much smaller in order to fit in terms of storage memory and also in order to operate in terms of processing requirements in smaller and lower capacity machines. And this can be done using quantization or model pruning. And concerning model partitioning, what we try to do with this technique is we split a big model into smaller parts and run different parts on different nodes on different devices. So we have the same model actually running, but not in a single machine, but in different machines. And this is the idea of model partitioning. The last, let's say, the last solution in our inventory is the RISC-V processors, which are, let's say, open and customizable processor that allow to process information on the edge efficiently and in a cost-effective, let's say, manner. And also with high speed, at least in terms of inference, with high speed performance when they are deployed in our architecture. So what we propose as an architecture is that we have, as you see here in this figure, we have the cloud, let's say, which is there for aggregating different weights from the federated learning setup and sending back the models or fine-tuning the models and sending them back to the edge nodes. Then we have on each edge node we have a Jetson Nano or a Raspberry Pi, depending on the architecture, where we are able to store local data that we use for the local training. And we also have the RISC-V processors in order to inference at very, let's say, fast speeds. So on the edge side, we have the sensors, the cameras, the smart meters, depending on the problem that we are examining. These data are collected, sent to the Raspberry Pi. The model is trained there, and the model is sent for execution back to the RISC-V processors. So everything is done locally, apart from the fine-tuning or the aggregation of the models, which takes place on the cloud. So then we have the two application scenarios that I was talking in the beginning. The first is the energy consumption monitoring. We have edge devices like sensors, consumption sensors, power metering sensors, humidity, light sensors, and so on. And we try to monitor all the conditions that take place in a building, in a home setup or in an office setup. Then we use the LSTM models to predict future energy consumption using the time series of the consumption that we get from the sensors. And based on the predicted high energy consumption patterns, we generate some recommendations for the users in order to perform some energy saving actions. Then in the second scenario, the multi-robot human collaboration, we use, as I said you before, computer vision models that allow a robot to understand when there is an obstacle in front, or to set to detect if the object is a human, or so it is movable, or something that is immovable, and then feed this information to the planner that decides to take an action. So this is the main task in the multi-human, multi-robot scenario. And this is a more detailed architecture of what we run in the edge device. So the cloud is here on the top corner, but here is the edge node. And in the edge nodes, you see that we have the data storage, where we store all the models that we have, the weights of the models that we have, and probably data that are collected from the sensors. We use this for fine-tuning the models at local level, or for training the models at local level, and we send the weights to the cloud for aggregation. And then we have, depending on the task, of course, we can have a compressed version of a large language model in order to generate text recommendations for the user, or we have the recommender systems algorithm that also generates recommendation, or we have the computer vision model that performs the object detection and obstacle detection. So this is the setup. The inference is run on the RISC-V, and all the training takes place on the edge, and the aggregation takes place at the cloud nodes. In terms of model slicing, what we try to do is to split the model in a proper way into smaller, let's say, segments, into smaller parts that can exchange, of course, information and data. And these parts, these segments, can run on different edge nodes with limited capacity, even on FPGAs. So we select a specific splitting strategy using an algorithm. It's called Sargent's bridge finding algorithm, which has a rather linear complexity in order to give results in a very short time. And then we use a depth first search algorithm in order to find the longest best way to connect the different slices to send data from some layers that are in one node to other layers that are in another node in this architecture. So we use specific tools, mainly Python and different libraries that are appropriate for training, such as PyTorch and NetworkX for splitting the neural network, and also for training it. Concerning the model compression, we use quantization, and we have different effects there. As I show you here, we tested with two different models, the MobileNet for image and the LSTM for time series analysis. And we have the impact that you can see here. We have a compression that is more or less 9 times the original size of the model. But of course, if we compress a lot, if we quantize a lot the model, we have a decrease on the performance of the prediction model. So we have an increase on the mean average error here. So we choose to use a less compressed model that has no significant increase on the errors that it predicts. And we use this TF-Lite version in order to compress and run the models at local level, at edge level. And this is these are some more results of the splitting and federated learning. So we have the different models running, as you see here, in different clients, and we try to evaluate the performance of the different compressed models when they run in a distributed manner. As you see here, the most compressed model has a bad performance because it has a high error, whereas the default model and all the medium compression, let's say, techniques have more or less the same error, the same performance. And that's it, more or less, the results that we have so far. Actually, we're working on both projects. These are two European projects that we're working on. One has to do with multi-human and multi-robot interactions in industrial setup, in construction sites, and in agriculture. And the other one has to do with energy efficiency and performance in home or office buildings. This is an ongoing work that we are doing for several years with the University of Qatar. And the key takeaways from this work is that our architecture is very appropriate for deploying large AI models on these resource-constrained edge devices. It combines several technological, let's say, features such as federated learning, such as compression, quantization, and so on, in order to achieve everything without losing too much in performance. And what we were actually working on, it's the compression technique, the model compression techniques. We are examining models, model quantization. We are also examining model pruning and combination of these two as a way to significantly reduce the size of the models in order to fit to the small devices while keeping the accuracy, the prediction accuracy of these models at high levels. And that's all from my side. I would like to thank you, and I'm open for questions if you have. Thank you.
Hey, Iralex, it's a very good work.
Thank you.
And just a few questions to you. One is related to the scalability. Like, have you tested it? I mean, how much, you said the room and the building. So how much area can it capture with the obstructions and without the obstacles?
Mm-hmm. Mm-hmm. If you're talking about the robot scenario,
Yes, the robots.
yeah. It depends on sorry about the opening things here. So it depends about the capabilities of the camera in order to see how much area you can cover. Of course, you can use multiple cameras, and you can use different modules in order to detect obstacles from the different angles, and then you need a way to locate everything properly. Actually, we have not put a lot of effort on this, and we have not some experimental results, but this is something that we'll soon have to do, because we are using in the industrial setup, we are using multiple cameras. So this is something that will soon have results. So
Right, you can add that in the result sections about
yeah,
the
sure.
abstractions. Now, coming to the resource constraints, like how much energy is there? I mean, how much backup it can support for how many hours, or what
Yeah.
would be energy support?
Yeah, this is a good question too. Actually, I don't have numbers now. I don't have the answer. This is something that we need also to work to measure in order to have results. This is the sure thing is that using edge devices usually, and also compressed models, we reduce the power consumption for sure, because because we reduce the size of the model, so we do reduce their their requirements, memory and energy requirements also. But yes, this is something that we also have to do as part of our future work. Concerning the inference thing that takes place in the risk where processors, usually they are more energy efficient than the Raspberry Pis or the other edge devices. But at least for now, I don't have exact numbers. So this is something to measure and so.
All right, that's a good work, and wish you all the best.
Okay, thank you. Thank you very much.
Thank you. Thank you so much for your presentation. Moving on to our next presentation, we have the paper title, Designing a System of Performance Feedback Communication in Higher Education. Dear presenter, could you please start with your presentation?
Yes, of course. I hope my screen is visible.
Yes, ma'am, it's visible.
So the title of this paper is Designing a System of Performance Feedback Communication in Higher Education. And the paper ID is 26. The authors are Dr. Jaya Chitranshi, Dr. Rajiv Divekar, and Dr. Reena Lemka. This paper is based on a patent that is published and the testing of this model is going on. So one of the important reasons to develop a feedback communication system is to enhance the student performance, because feedback is related with performance, as we discussed in the previous paper. The feedback will be effective only when it is specific, timely, and actionable. So this was recognized that you just can't give an open feedback and you can't give feedback in a generalized way. If you want the feedback to be effective and the recipient to work on it and improve his performance, then it has to be extremely specific. It should be given at the appropriate time, and it should be actionable, something on which the receiver can work. Feedback should focus on task and not on the person. That was also recognized, that whenever some feedback is being given to a person, the focus of the feedback should be on the performance itself and or on the task itself, and it should not be on the person or certain personality characteristics of that person. In case the focus is on the personality characteristics of the person, uh, the purpose of the feedback will not be served properly. A feedback communication system in higher education should encourage regular and ongoing feedback rather than a once in a year or once in a term feedback, because it has to be given on a continuous basis. Feedback also acts as a motivator by recognizing student efforts. This boosts their confidence and encourages them to work for excellence. Feedback system fosters critical thinking, communication skills, confidence, and self-efficacy among students, because based on the feedback they think how can they improve and how can they work on their performance. And proper communication is extremely important between the two, between the person who's giving the feedback and the one who is receiving the feedback. And then confidency and self-efficacy, the person or the student in this case should have confidence that he can work on that, on the feedback that is given to him. Otherwise, if the feedback is not focusing on the task and it is focusing on the personality of of the student, or maybe if the self-efficacy of the students or of the student who's concerned in this case is low, which means that if he feels he will not be able to improve, then certain other then the person who is giving the feedback should work on certain other mechanisms and should change his style of giving the feedback. Feedback from students helps design curriculum and program structure. So it's a two-way thing. Feedback should also be taken from the students, and based on that, curriculum should be redesigned and program structure. You can revise that program structure also based on this feedback. Feedback from teachers highlights areas where students can work and improve their performance. Thus, bringing in a robust feedback culture in the institution of higher education adds to students' performance as well as to the effectiveness of the higher education institution. So, when we studied the researches that have been done by researchers, we came across certain systems like Molloy and Booth in 2014. They tried to understand the role of feedback on learners' performance, motivation, and self-regulation. So performance, which means how can you improve performance, motivation, how motivated the student will be to improve his performance, and self-regulation, how will he actually work on his performance, because he has to work on it. Engert and Vigoda Gadot in 2007 in their study examined the relationship between goal setting, job feedback, and employees' formal and informal performance, and noted a positive relationship between job feedback and formal performance. So this study was done about job feedback and not about student feedback, but then there is a lot to learn. If something works in case of employees, and it actually works in the case of students also. Beatis et al. In their study increased self-efficacy by providing detailed feedback and compared this with negative self-efficacy. They concluded that performance feedback moderated self-efficacy, performance, and performance relationship. So the way feedback is communicated, whether it is focusing on the task or it is focusing on the personality of that person, the way it is given, that decides whether the person who is receiving the feedback will actually work on it or will not work on it, or will gain from it or will not gain from it. Poulos and Mahoney in 2008 highlight in their study the crucial role of perceptions about feedback, impact of feedback, and credibility of feedback. Azmat et al. In 2019 studied effects of providing positive and negative feedback on their position in terms of grades and studied the role of overestimation and underestimation of performance. The study concluded that feedback supports performance. So if it is given in the right way, if it is precise, if the focus is on the task, then the person should gain from it. McGrath et al. In 2011 concluded that development feedback positively affects a student's perception about fairness and support. So the perception, development feedback positively, it affects positively students' perception. So the way the student actually perceives the feedback that is being given to him is actually extremely important, and that can be controlled by by uh, uh, by making the focus of the feedback on the task and not on the personality of the person. When De Ridder et al. In 2015 noted, he also noted the link between positive feedback sharing and student feedback and student performance. So these reference, so based on all of the gap that is existing, a student performance feedback communication process flow and model for higher education was developed. The proposed process flow exemplifies the input, throughput, output process for feedback flow. The suggested model in this study takes into account monthly feedback collection, a 360-degree assessment, matching with expectations, continuous feedback communication, constructive and positive feedback, active listening, positive feedback scripts, constructive feedback modes of communication, and positive feedback scripts. Thus, an attempt was undertaken to develop the process flow and to suggest a stepwise model for performance feedback communication in higher education. So the objectives of this research study are to illustrate process flow of performance feedback communication and to suggest a stepwise model of performance feedback communication. So as we have discussed that this model and the system was developed for higher education, but then the testing and the trials that have been and the feedback from the stakeholders of the system, whatever has been taken, that has been taken from a management institute only. So this was the process flow. So student database, faculty database, feedback type, login, and model user database. These are some of the things that are there in the system, and student feedback management model. And this creates files for students, for faculty, for feedback type. It creates a report also where you can where the check user login is also there, and a model user summary can be created. So this is a glimpse of the actual system that was developed. The model that comes within the purview of this paper is given here. The stepwise model of performance feedback communication in higher education, which starts from monthly feedback collection, and this is 360 degree, which means the feedback is taken from all the people who are concerned or who are related with the performance of students. So the feedback is taken from the teachers, the feedback is taken from the research assistants who are conducting tutorials and who are guiding the students. The feedback is taken from their mentors, industry mentors, and mentors on campus. The feedback is taken from the buddies of the students, and the feedback is taken from other stakeholders in their performance. So suppose the student is appearing in a B school competitions, or he has sat for an internship project with an organization. So that feedback is also collected. So matching with, and then this is matched with the expectations that are specified, and this feedback is communicated to the student. So this is positive, which talks about the merits of the work that is done, and this also talks about the gaps that have been identified and how can the student improve his performance there. And if he receives a positive, the positive feedback that he is receiving, for that a feedback script is also prepared, which means the feedback that is going to be given to the student is written, so that the focus of that script remains on task and not on the personality of that person. And the mode of communication is in public. When positive feedback is given, other students are also there, the entire group is there, and then this feedback is given. If the feedback is constructive and it is focusing on the gaps also, uh, so this feedback, again the feedback script is prepared, so that the focus remains on uh, the task of task, which means the performance of the student, and it does not go to the personality characteristics of that person. And this feedback is given in private, which means there is nobody, and it is not given in the presence of other students or even other teachers or anybody. So and then this is supplemented with active listening. So this is basically continuous feedback communication is uh, also involves active listening. So if the student is discussing something and he's talking about his way of looking at the feedback or his understanding of the feedback, so that is listened to and that is heard by the person giving the feedback. So this model was developed, and this is under trial. And I would like to conclude this study, conclude this presentation. This model of performance feedback communication, which was actually developed for higher education, and then it was tested, and the testing is still going on only for management education, which means for MBA students. This entails input to feedback student management model through student faculty feedback type login and model users, because all of these are parts of the system that is developed. On the basis of a student faculty feedback type logins and model user databases, feedback reports are generated. These feedback reports are student reports, faculty reports, feedback type reports, and model user report. User login details are also checked. So the implications of this study, the process of performance feedback communication of students in higher education, this will be streamlined with the help of process flow model. The use of it will bring in more structure and clarity with respect to the feedback flow mechanism in institutions of higher education. The stepwise performance feedback communication model proposes and supports involvement of all stakeholders in performance management of students in higher education by collecting performance feedback from them. Stepwise process Stepwise process will make the feedback system simple and easy to implement. With student performance, the overall performance of the institute will enhance if the student feedback model is implemented. Thank you.
So welcome back, Jaya, with the second part of your research.
Thank you.
I have raised the same question about your feedback in the last presentation. So I think this paper answers that.
Yes, ma'am. So,
And the same suggestion you need to follow, because I would just like to ask you one thing is, what were your observations after how much you have implemented? Based on that, what were your observations?
uh,
Observations on this model, like
observations on this model. Okay, ma'am. Actually, what I have observed is that when you have a system in place, it gives you a more, it gives the entire feedback process a more scientific approach. because feedback scripts are also prepared, and then feedback is to be given to students, and then you need to keep the focus on the task only. You shouldn't talk about certain personality characteristics. So all in all, it has made the system a more scientific one, and people are giving feedback because then they have to do it. So everybody has actually realized the importance of giving feedback, and then giving feedback in a very very scientific way, and keeping all the biases aside, and keeping the focus on the performance only. And this is how, and I have also seen that students are also benefiting from this, because now the focus is on their performance only. So not on the way they are doing it, because that is all part of mentoring and other things. So this paper is actually focusing only on feedback communication. How should it be communicated, and what process should be followed? So actually the focus is on one thing, which is preparing the feedback script, and there should be frequent check-ins. So that is also being done. It has to be done quite often. So it's not that you are giving the feedback once in a while. It has, like we discussed in the previous one, that it has to be woven with the semester that is going on. So that should go on. And then a more objective system. It has a more objective system of feedback giving. And
All right.
all of this.
Yeah, 1 minute, Jaya. See, so what happens is when you give a feedback, mostly you would have seen if you are in academics, the feedback is given only when the things go wrong. Even when you receive the product, if it is Amazon delivery or something like that, as long as you're not giving feedback, very few people are sincerely giving the feedback, what I mean to say. So, and most of the student, they just tick the options which is given to them in the checkbox without even reading them or without even bothering to read them. So in your talk or in your presentations, you are repeatedly using the word a scientific way. So what is a scientific way? Can you tell?
Scientific means, yeah, okay. So the system, this is a system which is more objective, and its frequency is also determined in advance. So a feedback has to be given, and there it has to be actually given on a weekly basis for different things. So those slots will be fixed in the timetable, and we have all of this in the system, and we are doing that. And then for every student, you have to prepare the feedback script also. So the script will be with you, because we are actually testing, and this is going very well, because the feedback script is whether your focus is on the performance or what are you actually going to communicate to the student. So students are actually students are very very happy, because they are receiving feedback continuously, because then only their performance will increase. They actually know where to improve. Otherwise, if it is not part of the system, and feedback communication is not there, and you are not having a model in existence in your system, then it will happen whenever people will feel like giving it. So, and giving this feedback is compulsory and mandatory, and it is part of the system. So this will be there, and the person who is giving the feedback has to maintain the records also, what feedback is being given. And like in our institution, we have another system which is developed by students. This is called digital runbook. So on that, we have to upload some. It like other students can't see somebody else's feedback, but then we put it there also. So it is all documented. So it will remain there, and at the end of the term, we will see how has the student actually improved over the year, because that is the purpose.
All right. So good luck with your research. We'll move on to the next presenter, please.
Okay, thank you, ma'am.
Thank you, ma'am. Thank you for your presentation. We
Thank
move
you.
on to the next presentation. We have a paper title on the fast track to full gold open access. Dear presenter, could you please start with your presentation?
Hello, good Good morning or good day to everybody. Just a second. There you go. I presume you see my slides.
Yes, the screen is visible.
Okay, thank you. So the main point of this research was actually to determine what is actually happening with the publishing models, and if there are any issues, how to address them. So there are typically two publication models, subscription-based and open access based. So in a subscription-based model, you have a situation where the author is free to publish, and it is available for the reader through the purchase. The problem, of course, is that it is expensive for libraries and universities which are paying those subscriptions. So to address this question, open access model was devised, which is, well, closed for the author in the form of the APC payment, but is free to the reader. So the situation has been reversed. Of course, the problem here is that the APCs are not that inexpensive and are again typically paid by libraries and universities. And of course, a couple of other issues has been added to the mix of, for example, the predatory element like predatory journals and so on. So has the problem been solved? So you have expensive subscriptions, APC payments for libraries and universities in both models. So that is a general case. There are some exceptions, but that is the general case. A typical APC is about $3,000 with the standard deviation of $1,352. But it can rise even to 10,000 or more than $10,000, which can of course be a challenge even for a scientist that is coming from the first world country. So what is the solution? Well, is it the model exclusivity to which we are going, to the open access model? Well, I would argue not. Why? Because this will only make the issues worse and potentially even deliver new problems. Why? Because there won't be any mechanism to deal with the issues, because that will be the exclusive model. On the other hand, we could have inclusion and competition. So have all models, subscription, open access, and all the varieties thereof. In this way, you will ensure improvement, competition, and potentially even give rise to better publishing models. During the research, I have found out quite an interesting fact. That is, if you look at this graph, this is the subscription model in the number of documents, and this is the open access model in the number of documents. So both publication models have plateaued, and I have checked the data for the 2024, and the trend continues. So the question is, what happened? If you go to history and look at the historical data, the same has occurred in the World War I and the World War II era. Now the data is too scarce to make any overly certain conclusions, but it seems that scientific publishing reacts to tumultuous world events. So the question now is, what next? What will happen next? Perhaps a new publishing model, perhaps stabilization, perhaps the next industrial revolution, which also approximately well coincides with these trends. So what can we conclude? We can conclude that open access, it seems, hasn't solved the price issue, which was the main issue behind the open access model. The price, that was the issue, the price. And has added some other issues like predatory journals, sham articles, and so on. For example, the Nature has published in 2023 that more than 10,000 articles, sham articles, have been published, which is incredible. You have more than 10,000 fake articles floating around. The immediate relevant solution is to have every conceivable model, every model that is in existence, functioning in parallel. And of course, that which cannot function will by itself go away. And it also seems that scientific publishing is at a crossroads. What will happen next is difficult to project, but we will, I guess, find out in a while. So with this, I will conclude my presentation and yield back to the moderator.
Hey, Robert, Professor.
Yes,
Yeah. Was it a study paper or an implementation paper?
I didn't hear you. Could you repeat?
Have you
Didn't
implemented the
hear you.
model to, can you hear me?
Yes.
Yeah. Have you implemented any study to identify the fake articles, or is it your literature study report paper?
So it's from the literature. It's a study being done and published in Nature in 2023.
All right. Now, the thing is with the upcoming sites of Scopus, we have a Scopus, we have SCI index papers, and we have ResearchGate. So, how will you identify, and what would be the parameters to identify the particular article is fake?
So this research was not about the fake articles, but about publishing models.
Okay, so what were your observations on the publication models?
The reason why Scopus was selected, I guess that is at least part of the question you're asking, is because it is the most encompassing relevant database. So that is one question. And the second point is that if open access was to solve the price issue, and that was the main issue, people forget that, but the transition from subscription to open access wasn't because of the openness, because if something is in a subscription, that is not closed science. You have to pay, like you have to pay for the car or anything else.
Right.
So the main issue was price.
Mm-hmm.
And unfortunately, this hasn't been solved. The APCs are very expensive, and it is also quite a problem to pay them, both for the authors and for the universities and libraries. So after the analysis, the point is to not make the transition to full open access, which some publishers want to do, because that will make the situation even worse, but to hold both open access and subscription in parallel so that they can compete. In that situation, you will have the road to science open from the author side and also open from the reader side. And the competition of the models should lower the price. So that's the gist of it.
Yeah, thank you. And it's really a good study. Thank you, Robert.
Thank you. Thank you.
Thank you. Thank you so much for your presentation. Moving on to our next presentation. We have the paper titled Student Performance Management in Higher Education, a Bibliometric Analysis. Dear presenter, could you please start with your presentation?
Yes. I hope my screen is visible.
Yes, ma'am, it's visible.
So this is another paper. The paper ID is 25, Student Performance Management in Higher Education, a Bibliometric Analysis. So, and the authors are Jaya Chitranshi, Rajiv Devekar, and Reena Lenka. So the focus of this paper is on studying student performance management literature, the authors, the countries that are working in this area, that are coming out, that are coming up with research in this area, and that we have tried to identify through this paper by using the technique of bibliometric analysis. So to satisfy its high purpose of shaping, developing, and directing adult minds, and institution of higher education should focus on performance management as its top priority. When there are clear phases and benchmarks in the performance management process, the aim of transforming students into high achievers can be achieved, because you have identified the parameters and you are working in that direction, and you have a more structured approach to feedback giving and a more structured approach to performance. And then you can expect students to focus on those on the parameters and to work according to the feedback that they are receiving, and this will help them to improve their performance. The objective of this paper is to identify any research gaps in performance management in higher education and make recommendations for future courses using bibliometric analysis. So some amount of literature is available. Like Kim explored the impact of learning management system on students' performance, and Mozaim in 2020 observed that web-based learning management systems are gaining more and more attention from institutions of higher learning. A study by Jain and Gupta in 2019, that was it was an empirical investigation of the impact of knowledge management systems, that is KMOs, in institutions of higher education. Megha and others presented a theoretical framework that links academic achievement to emotions, self-regulated learning, and motivation. De Kremper et al. In 2013, which means about 12 years ago, highlighted that existence of a performance management system, communication, and tighter control led to higher performance in higher education. Sundar in 2016 suggested through their study that a quality culture should be fostered in higher education institutions for better performance of students. Besides, Taylor and Brains in 2012, which means about 13 years ago, emphasized prescribing to the balanced scorecard approach for higher performance, which focuses on targets and their weighted scores in institutions of higher education. Cullen et al. Also highlighted the importance of key performance indicators aligned with the strategy. So if we are talking of the institutions of higher education, there will be some key performance there should be some key performance indicators for students, and there has to be a strategy also. So Chen et al. In 2006 propagated the role of strategic themes and targets, and quantified measures in enhancing performance. And Heldenko in 2015 highlighted the use of balanced scorecard approach and its alignment with the strategy for managing performance. The study suggested the scheme of plan, do, check, and act for higher education, which means first you should plan everything. What are the parameters? How much time the students have? How will they achieve those targets? Everything needs to be pre-planned. Then the students will work for those targets. Then you check performance or measure performance, and then act accordingly, which means you can give some feedback in case so that the performance improves. And plan, do, check, and act can go on for every term. So there were some research questions that were raised. What effects do performance management system creation and implementation have on students' academic achievement in higher education? Which elements have a major impact on how well a student succeed in higher education? How well can a decision tree algorithm based predictive model predict student performance in higher education setting? And how does it stack up against other categorization algorithms? But in this paper, the focus is on knowing. Uh, we actually did not focus on all the questions. We focused only on the literature that is available. What kind of researches are happening with respect to student performance management in higher educations, and uh, who are working, which countries are working, which authors are working, and what is the present, which are the keywords, on what keywords the studies are focusing to analyze. So the methodology that was used was to analyze this was the objective, to analyze the research work that exists in the area of performance management and suggest future direction. This research paper is based on bibliometric analysis to siphon relevant information in the area of performance management, focusing on most cited documents, prolific authors, the universities that are working in this area, journals, country, territory, and subject areas. The paper further uses a Scopus and VOS viewer to identify clusters of items to understand research focus in the area of performance management. So this was some of the background work that is actually done to understand how the research in this area is going on. So these are some of the results of bibliometric analysis. So we can see the documents by year, and we can see that after 2017 there is a rise, and in 2022-23 papers are increasing. So there were in 23 there were 125 documents, around 125, less than 125 documents, especially focusing on the student performance in higher education, student performance management. We also tried to these are documents per year by certain sources. So there is and these were public performance and management reviews, Journal of Modeling in Management, Measuring Business Excellence, International Journal of Productivity and Performance Management. So like we can see that public performance and management review, there is a slight increase in after 2019 in terms of the papers that are being written. And in the third figure, we can see the documents by authors like Hirstov and Sonila and Yuko. They are coming up. They have done a lot of work in the area of performance management. These are some other results by affiliation and by country. So like the first three university, Tampere University, Cranfield School of Management, Cranfield University, they are actually working. So researchers who are affiliated with these universities are actually working in the area of performance management. And on the right side are documents by country or territory. To United States is on the top, followed by United Kingdom, Italy, Australia, and then India. So, this also shows that there is a lot of interest, and researchers are actually working in these areas, and certain advanced countries of the world are actually focusing on this area. Then documents by subject area. So we can see that there are 52.0% documents, which means more than half of the documents that are published in the area of performance management are coming they are coming from business and management. Followed by social sciences, 13.9, followed by decision sciences, followed by economics, and then the rest of the fields are coming up. So a lot of research is happening in the area of business management, in the journals of business management, and then followed by social science, followed by decision science. And this shows the clusters. So this is generated by WAS viewer, and uh, certain clusters where the research within the area of performance management is actually happening. And these clusters have been discussed here. So we could see 5 clusters, and first cluster was found to have 23 items that showed their linkages with performance management. Some of these items were humans, employees, organization and management, leadership, quality improvement, total quality management, and the like. The results indicated that the major focus of research in this area of performance management is on humans, organizations, management, leadership approaches, and quality management. So all these terms have been taken from WAS viewer only. Cluster 2, the cluster 2 had 21 items. Some of these items of this cluster were decision making, information management, innovation, managers, human resource management, performance measurement, sustainable development, sustainability, and others. This result and similar words. This result indicated that an important focus of research in this area of performance management is on such themes as decision making, information management, innovation, human resource management, performance measurement, sustainable development, sustainability. Cluster 3, this had 3 items: human resource management, and motivation. This result indicated that a bit of focus of research in this area of performance management is on human resource management and on motivation. Cluster 4 had 2 items that were balanced scorecard and public sector. This result indicated that a minuscule amount of focus of research in this area of performance management is on balanced scorecard approach. Cluster 5 had 1 item, performance appraisal. This result indicated that an extremely minuscule amount of research in the area of performance management is on performance appraisal. So from these, actually, we get an idea what research is actually happening in the area of performance management, and how can we, and which countries are working, which authors are working, and where are the gaps, so that more research and the research that is happening in the area of performance management is not focusing only on employees. We can take certain things, like employees will also have targets, their performance will also be measured with respect to those targets, they should also get feedback. So because that works in case of employees, so it only means that if something is working in the case of employees, it will also work in the case of students, because they are also human beings. So any human works when his targets are specified. Those targets are smart targets, specific, measurable, achievable, relevant, and time bound. And he's getting continuous feedback to keep working on his performance. And there is a term for which the performance is being managed. So, to conclude this paper, from the year 2016 to 23, 855 documents were retrieved from Scopus. there was seen a sudden spurt in articles in 2022 and 2023. We could find that the top 3 authors in this subject were Hristov, Sonila, and Yuko. The top 5 journals published in this area were found as Public Performance and Management Review, Journal of Modeling Management, Measuring Business Excellence, International Journal of Productivity and Performance Management, and Production Planning and Control. The top 4 universities publishing on the subject were found to be Tampere University, Cranfield School of Management, Cranfield University, and University of Warwick. The countries that are publishing in this area were found to be United States of America, United Kingdom, Italy, Australia, and India. Half of all the documents, which means about 52%, were found to be written in the domain of business and management and 14% in social sciences. 5 clusters of performance management research were identified through VOS Viewer. So this paper basically focused on performance management, and it was performance management, a bibliometric analysis. So this model will help transform students with respect to their performance and thus help them in their academic and corporate journeys henceforth. The students thus will benefit from the stepwise process of performance management in terms of their multifaceted and all-round development. The work organizations will also benefit by procuring performers. This will further create and boost a high performance work culture in the organizations. If we go by the analysis and the research that has happened in the area of performance management. So this was the paper on bibliometric analysis of performance management.
Thank you, ma'am. Thank you so much for your presentation. Ma'am, you have any questions?
No, Jaya, because I understand it's a continuation of the same work. So please carry on. No
Yes.
question from my side. Yeah, good luck.
Thank you, ma'am.
Thank you so much. Thank you.
So this brings us to the end of our presentation. I would like to ask our session chair, Dr. Preeti ma'am, to share some insights and feedback on our presentations today.
Oh, yes. Thank you, Aarti, for that. We had a very good presentations from different fields. Like we started with Byron with the classification of fetal death. Then we moved to the research of Jaya, where we had 3 papers based on the higher educations and the feedback in the academics. Then we have Vera Lemus, who were talking about the AI models, and Professor Robert, who were talking about the APC, especially about the Scopus. So it was good to listen from all of you and all your research area. So wish you all the best and wish you lots of good publications. So that's all from my side. Thank you so much.
Thank you, ma'am. Thank you so much for your valuable feedback. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We would be happy to have you in the 11th version in 2026. All our presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2025. I would also like to thank our session chair, Dr. Preeti ma'am, for chairing the session. A token of appreciation to the chair on behalf of Team ICICT 2025 and Global Knowledge Research Foundation and partners. Thank you, ma'am. Thank you for your valuable presence. Now, I would kindly request all the participants to please switch on your cameras so that we can have a quick snapshot of the virtual conference. Thank you so much. Stay safe and take care. Bye.
Thank you, Dr. Preeti, and thank you, Ms. Aarti. Thank you so much.
Thank you, ma'am. Thank you.
Thank you. Bye.
Bye.